this session, we discuss about solving exact differential equations. So we start with an appetizer. To solve the equation 5x power 4 plus 3x squared y squared minus 2x y power 3 dx plus x cubed y minus 3x squared y squared minus 5 y power 4 dy equals to 0. So the first thing, we realize that this equation is in the form m dx plus n dy equals to 0. So where m is given by 5x power 4 plus 3x squared y squared minus 2x y power 3, and n is given by 2x cubed y minus 3x squared y squared minus 5 y power 4. So we test whether the equation is exact or non-exact by using the condition partial m partial y equals to partial n partial x. So in this case, partial m partial y, so the first term has no y, so the derivative is 0. Second term, so dropping these two, we have 6 x squared y, and then drop these 3 minus 6 x y squared. And this partial n partial x, first term has an x, so drop these 3, we have 6x squared y minus 2 by 3 is 6 x y squared. And this last term has no x, so the derivative is 0. Now clearly, partial m partial y, which is 6x squared y minus 6x y squared, is exactly the same as partial n partial x. So this shows that the given equation is exact, and so there exists a function f of xy such that this differential equation, which is of the form m dx plus n dy, is the same as partial f partial x dx plus partial f partial y dy. So clearly this means that m is the same as partial f partial x, and if we relate m in this equation, five x power 4 and then plus 3x squared y squared and then minus 2xy cubed. And then n is given by partial f partial y which is given by 2x cubed y minus 3x squared y squared minus 5 y power 4. So let's call this equation 1. Let's call this equation 2. Now, from 1, we can get f by integrating with respect to x. So 1, integrating equation 1 with respect to x, we get f, i.e. integral of partial f partial x with respect to x is the integral of 5x power 4 plus 3x squared y squared minus 2 y power 3 dx. So this and this cancels out, so integral derivative inverses of each other, so we remain in f. When you integrate this term, you get x power 5 plus this term will give us x cubed y squared. This term will give us minus x squared y cubed, and then plus a constant of integration, but that constant we write it as a function of y. Now, so call this equation 3. Now we again now with this answer, we now differentiate it partially with respect to y. Now differentiate equation 3 partially with respect to y. To get, so if I differentiate this, I'll get partial f partial y equals the first term will give me 0 because there's no y here, but this will give me 2x cubed y, and then minus, this will give me 3x squared y squared, and then plus g prime of y, because this is a function of y. So I call this one 4. Now, remember equation 2, which is n, is the same as partial f partial y. And now this, our new equation 4, is also defining partial f partial y. So it means that equation 4 and equation 2 define the same value of partial f partial y, so we can equate them. Now, equation 2 equals to equation 4 because all of them are defining partial f partial y. So therefore, this implies that 2x cubed y minus 3x squared y squared plus g prime of y should give us 2x cubed y minus 3x squared y squared, and then minus 5 y power 4. That is what we have in equation 2. Now, this equation reduces to, so this term and this term cancels out. This term and this term cancels out. So which means we'll have g prime of y equals to minus 5y power 4. So these are derivatives. So then to get g of y, we integrate this equation. So let's call this equation 5. Now integrate with respect to y, we get integral of g prime of y dy equals to minus 5 integral of y by 4 dy. So this will give us g of y equals to minus y power 5. So remember what we discussed previously on the steps of solving for g. You don't add the constant of integration. We are just interested in the function itself. So if I call this 6, now replacing 6 in the equation that defined the function is 3, we get f of xy equals to, the first term in 3 is x power 5. And then next is x cubed y squared. Next is minus x squared y cubed. And then plus g, and now we have found g to be minus y power 5. So therefore, the solution is f of x, y equals to c, which is x power 5 plus x cubed y squared minus x squared y cubed minus y power 5 equals to c. Remember, we say that the solution to the exact differential equation is given by f equals to c. So this is now the implicit solution to that given differential equation. X power 5 plus x cubed y squared minus x squared y cubed minus y power 5 equals to c. Let's give another example. Number 2, solve. Sine of y plus y cosine of x dx plus sine of x plus x cosine of y dy equals to 0. The next equation. So to solve this, we start by testing whether the equation is exact. So our m is sine of y plus y cosine of x. Our n is sine of x plus x cosine of y. So the test is to show that partial m partial y is partial n partial x. So from this, partial m partial y is given by cosine of y plus cosine of x. And from this, partial n partial x, the first term will give us cosine of x. Second term will give us cosine of y. And it's very clear that partial m partial y equals to partial n partial x. So clearly, partial m partial y is the same as partial n partial x, which is the same as cosine of x plus cosine of y. So hence, the equation is exact. The given equation is exact. And since the equation is exact, so this implies that there exists a function f of xy such that m dx plus n dy equals to partial f partial x dx plus partial f partial y that the nature of an exact differential equation. So we see that m is partial f partial x, which in this case m is given by sine of y plus y cosine of x, and n, which is partial f partial y, is given by sine of x plus x cos of y. So you call this equation 1, you call this equation 2. Now we can get f from either equation 1 or equation 2. So if we go to equation 1, to get f, we are going to integrate with respect to x. So we integrate equation 1 with respect to x to get f of xy. This will give us f of xy equal to the integral of sine of y plus y cosine of x dx. So which will be f of x comma y equals to, when you integrate this, you get x sine of y. So remember, sine of y is just like a constant, say 10, because the main variable of integration here is x. So sine of y will give us x dx, plus when you integrate a cos function, you get a sine function. And then plus a constant of integration, but we write it as a function of y. So call this equation 3. Now we differentiate 3 with respect to y. To get so then partially differentiate 3 with respect to y. to get partial f partial y equals to, so this, when we get y, we get x cosine of y, and then this will give us plus sine of x, and then plus g prime of y. So let's call that equation 4. Call this 4. Now, equation 4 and equation 2 define partial f partial y. So equation 4 equals to equation 2. Both of them define partial f partial y. So we can always equate them. So which means x cosine of y plus sine of x plus g prime of y is the same as equation 2, which is sine of x plus x cosine of y. When you do this, some terms will cancel out, like x cos x, x cos y cancels out, and sine of x, sine of y cancels out. So this means that g prime of y equals to 0. Now, integrating, I call this equation 5. With respect to y, we get g of y. Now, when you integrate 0, we just get a constant, say k. So therefore, if I call this 6, replacing 6 in 3, because 3 is the one that defines the function, we get f of x, y equals to x sine y plus y sine x plus this k. So the solution f of xy equals to c, so which will be x sine y plus y sine x plus k equals to c. And remember, k and c are just constants, so we can say x sine y plus y sine x equals to, just say a, where a is a constant, c minus k. So that is how we solve that equation. So we give more examples in the next session on exact differential equation.